meeting. Let's see. Started by you. Let everyone know they are being recorded. You are being recorded. Letting you know. So differentiation, hyperbolic functions. So outcomes. At the end of this learning unit, you should be able to define a hyperbolic function. Draw the graphs for a hyperbolic function. Differentiate hyperbolic functions. Did you hear that? Those are the things you need to know. Now, they're saying that hyperbolic function. So a hyperbolic function sine of x is written as sinh of x. Some people call it shine, some people call it sinh. Pronounce it, okay, in this work, they pronounce it as shine of x. Now, the hyperbolic of cosine of x is written as cos of x. The functions are defined as follows. So meaning that the hyperbolic function can be defined in terms of exponential functions. So therefore, it's defined as e to the power of x minus e to the power of negative x over 2. Don't forget this. This might be useful in the exam or in the assignment. Cos of x is equals to e to the power of x plus e to the power of negative x over 2. Now they say the other hyperbolic functions are defined as follows. The hyperbolic function of tan, some people call it a thing. The hyperbolic function of sec, some people call it shek. The hyperbolic function of cosh, some people call it a coth. The hyperbolic function of cosec, some people call it cosec, coshek, something like that. Are we all together? Now, activity 1, I think they want you to represent. Okay, let me not tell you. Go and do it. Now, they're saying that the hyperbolic function have properties similar similar in some respect to the ordinary circular or trigonometric function. From any formula connected trigonometric function, the corresponding formula connected to hyperbolic function can be obtained by replacing each circular function with the corresponding hyperbolic function. If the sign or every product implied products of two signs is changed, this is clearly shown in the following table. So in this table, in this short paragraph, they're just saying that hyperbolic functions are similar to circular or trigonometric functions, as you know. For example, the properties. For example, sine squared x plus cos squared x is equals to 1. So with hyperbolic function, there's a minus in between where you have cos squared x minus sin squared x is equals to 1 or shine. Now, do you see the properties, guys? Look at the properties. Do you see that they are similar? They're not the same.
Yes.
Am I? Oh,
Yes,
I
ma'am.
thought I was talking to myself. So they say that the graphs for the hyperbolic function, because you have to know how to draw them, they're telling that the graphs for y equals to x, you know the graph for y equals to x, and you know the graph for y equals to negative x are also known to us. Now, from the graph, you can then draw these graphs to get y is equals to the hyperbolic function of sine, and y is equals to the hyperbolic function of cos. So these are the graph. The top part is the hyperbolic function of a cos. This one here, which is cos. Now this is a hyperbolic function of sine. You're seeing the graphs, guys? Yes or no? You're seeing the graph, or you can go and see them in your. Thank you. So now they're saying that we see that, okay, so these are the properties of this graph. They say with the hyperbolic function of sine is defined for all x values, meaning that the hyperbolic function of sine, x are element of all real numbers. I don't have to teach you that is the domain of the function. And then at sin equals to 0, the answer is equals to 0. Do you see that? So don't say I didn't ask you questions in the exam and then there's things that I asked you and I didn't teach you. They're all here. Now, this part here is the range. This part over here. Here, draw, man, draw. They said read. This part over here is the range of this hyperbolic function. And they're telling you that the hyperbolic function of sine is what's this? is an odd function, meaning that if you put a negative, if you put a negative x inside, you'll get a negative sinh x. So the curve is symmetric about the origin. Now the sinh has the point of inflection at 0 and 0. You also have to go and read these properties. This is important for you to understand and learn. If you have any questions, send me an email. Do not hesitate. Now they say it can be shown that any cable that hangs freely between two support hangs in the shape is the shape of a hyperbolic cosine curve. Example of such curves include telephone lines and electric power cables strung from one pole to the pole or tower to another. So they are saying that the shape of a hyperbolic cosh, this shape here, is the shape of electric what's this, guys? Electric towers. When you have a tower here and you have a tower here, and then the tambos, your ropes are passing there between two towers or telephone towers. They're saying it's in the shape of a hyperbolic cosh. That's what they're saying. Now here we have a hyperbolic function of 10. And then these are the properties. Please go learn them. If you don't understand them, send me an email. Now, differentiation of a hyperbolic function. The derivative of sinh, cosh, and tan are easily found from the exponential definition. So this is how they found it. You don't have to know how to derive them because you will be given a table. Everyone is getting a table. You're getting a table. Everyone is getting a table in the exam. So you don't have to learn how to do this part. Just understand how to do it for future uses. But for Math 2691, you don't have to. Now let's go to example 1. Let's go to example 1. You tell me. You look at the table and tell me what we're going to do. I think I'm hungry now. Find the derivative of sinh squared x. Please tell me, guys, when I'm hungry, I write whatever I want. In most cases, it's not correct. What do we do?
Well, it's sinh x squared. So when you derive that, you do a chain rule for it.
Are we agreeing, yes or no? Guys?
Yes, it is a chain rule.
Okay, thank you. But you have a nice table here. We start with the table. Let's go do that. See. The gentlemen are sleeping now. I don't know why. Why? Okay, so they are saying if you have sinh, then the derivative will be cosh f prime. Now, in this case, we agree that our f is equals to x. Are we all together?
Yes, ma'am.
So they're saying that y is equals to sinh or shin of x. We can write this as sinh of shin of x squared. So therefore dy over dx, this is the chain rule, well done, of x times the derivative of this, which is this one over here, which is cosh of x times the derivative of f of x. In our case, f of x is x times 1. So this is equals to 2 sinh of x times cosh of x. Just like that. No too much, no needed too much. Let's see if we are right. We don't need anything else. And we are. Now let's go example 2. This is one of the easiest section, guys. I want you to every marks. Take every marks. Take every marks. This one, take every marks. Okay. This one is sinh as well. And we know that sinh, the derivative of sinh is what is cosh of f of x times f of prime of x. Right? Now, what's going on here? Now I'm confused. What's going on? Please
Got a
unconfuse me.
A product rule and a chain rule.
Thank you. We have a product rule and a chain rule. So therefore, dy over dx will be what?
Sin 2x.
Sinh 2x.
Then the f of x of cos 3x.
So let's write it like this, the way they'll write it, d of cos of 3x. The derivative of this, yes, plus
the derivative of sinh 2x.
the d over dx of sinh of 2x, yes,
times cos 3x.
Cos 3x, thank you. Remember the chain rule, you can start with sinh, you can start with, as long as you start. So then this will be sinh 2x times what?
So we look at our table and it says sinh f of x, sinh fx, and then f of x.
Thank you. So sinh of, what is our f of x in this case?
It's 3x.
Thank you. 3x times the derivative of f of x, which is 3, plus, what is this? We know it's this one over here, which is cos of f of x is 2x times the derivative of f of x times 2 times cos of 3x. So now this is equals to 3 sinh of 2x times sinh of 3x plus, what was that? 2. Okay, 2 cos of 2x times cos of 3x. And that's the, any question?
No.
And that's it. That's it. So, are we having the deal of doing the question now or words? Or you guys are tired? I can just let you do that question and enjoy it, and then I don't come back. Example 3 on page 44.
I think maybe let us do it in our own time, and then if we have questions for you, then we bring it in the next section.
No problem. No problem.
What does everyone else think?
Yeah, I
Thumbs up.
support that. I'm in support.
I don't think anything.